The only thing that will change the equilibrium constant is a temperature change. KQ, and as we said today, rate constants only change upon a change in temperature. If you just change other settings, like maybe a volume or an amount, a concentration, you can see a reaction shift. Hopefully you all learned that with Le Chatelier's principle. But the actual number, the ratio of products to reactants, that will not change in number unless the temperature of the reaction changes. Okay. One example about that here. Let's consider a reaction between maybe chlorine. I'll write this Cl2, and then iodide, making I2. And chloride. And this is going to be an exothermic reaction. They would tell you that. So who can tell me what is the Kc equilibrium expression here? How would you write that expression given our balanced reaction? We leave out the solid. And so if it's exothermic, that means that heat is what? A product or a reactant of the reaction? Plus heat over here. That means that the enthalpy is released, okay? And the reaction can shift one way or another if you add or take away any of these three. If you disturb the equilibrium, say it was already at equilibrium, and you change those amounts, then you're changing these amounts, and the reaction will shift one way or the other so that K stays the same. K does not change with adding or taking away concentrations. But if you add or take away some heat, in other words, change the temperature, that will change the number of K. Okay, really important to understand. So as the temperature increases, think of that as being something like more heat on the product side. The products are now too heavy relative to the equilibrium point because we've added more heat. Then it's going to shift away from the side that's too heavy, shift to the left. If you shift to the left, then we're going to see an increased concentration of the reactants, which means the denominator is going to go up. The chloride, which was a product, is going to have to be consumed to shift to the left. So what we're seeing here is that K would go down. That's true for any exothermic reaction. At higher temperatures, they become less product favored. Less products, more reactants, lower K value, whether it's a Kp or a Kc or a Kq. Okay. It's best to operate exothermic reactions, those that release heat, at low temperatures. Okay. Then the reaction shifts more this way to the products, and you get the products that you want to make in the largest amount.